Let's take a look at the most common CVT, the variable diameter pulley transmission. This transmission uses a belt to transmit power from the input shaft to the output shaft. By axial movement of sheaves, the overall gear ratio can be adjusted continuously, as indicated by the red markings. This is only possible through the movement of the sheaves. When the pulley sheaves are far apart, the pulley is just like a small gear. When the sheaves are close together, it acts as a large gear. Since the length of the belt must always be the same, both the sheave of the input and the output must be adjusted simultaneously. If a cross-section through the belt is created, we can see its V-shaped design. That way, a movement of the belt is possible. Scooters usually use a V-belt made from rubber or polymer. More often than not, these are cogged V-belts. That way, the belt has enough flexibility to adjust itself to the variable diameter of the pulleys. Another way of transferring power from input to output is a steel belt made of many steel elements. The steel elements are held in place by several thin steel bands that bend easily. Vehicles with a power of up to 300 horsepower can use such a metal belt. A CVT chain is composed of rocker pins that connect at least 2 plates colored red in this animation. The plates can be moved. A CVT chain is made of many rocker pins and plates. That way, a design, as it is shown here, is achieved. But how do the sheaves move? When it comes to the variomatic, which is often used in motor scooters, we find several centrifugal weights that will move one sheave. As soon as the scooter moves, the pulleys turn and a centrifugal force acts on the weights. The higher the speed of the scooter, the higher the centrifugal force on the weights. When another sheave is placed on the weights, this sheave will move as soon as the weights are pushed outwards by centrifugal forces. Fixing one sheave axially will result in an axial movement of the other one when the motor scooter accelerates. When it comes to automobiles, this technology won't work. In modern cars, hollow shafts are used to adjust the position of the sheaves via oil pressure. Here, oil pressure is supplied by an oil pump.
So, that's it for now. But there is more. If you want to know more about CVTs, check out the animation of Learn Engineering. Or do you want to watch other animations made by me? Then click here, or just support my channel.